The next part we're getting into is actual program control. This is how you execute your entire program. Normally, the processor processes it like reading a book, left to right, top to bottom, and start to finish, and then repeat. But you can have different areas run or not run, jump over certain sections, and this might be whether a process that only runs once in a while, you can jump over that process, that section of rungs, and ignore it until it's required and then run it. Or you can run your regular program, and if something happens, you jump out to another program, run that, and then return. That would be called a subroutine. Generally, jump to subroutine, or JSRs under Alan Bradley. Now, Omron has a couple of terms. One of the common ones in the industry was an MCR, Master Control Relay. Now, usually, before all the safety got so finely tuned and developed, there would be a master control relay. So if somebody pushes the e-stop anywhere on a machine, what that would do would disable a relay, which would drop out and cut off all the power to the output modules, which means everything stops. And it would also stop any motors that are running. So basically, it brings everything to a screaming halt. Now, that's a master control relay. That could be programmed in. Before PLCs, it was actually hardwired in and would shut the power off to massive amounts of relays and equipment. Now, Omron uses MC and MCR. It's the same thing, slightly different name. MC marks the starting point of a master control region, and MCR marks the end. So you can take a chunk of your program, certain number of rungs, put an MC at the beginning and an MCR at the end, and if that master control input is turned on, that part of the program, all of those rungs will be executed and processed. And if MC is disabled, then of course that whole section is turned off. You have an MC command, and you have some kind of a push button. Could be an e-stop, could be something else, could be an output, a variable, and the output will then disable anything between these two labels. So that is an MC, the start and finish of a controlled region. Variables use that. Again, that can be done with safety equipment, can be done with processes that are only run sporadically. So there's under the help menu, you can do a search and find this section on that. Another way of doing things like jump, I mentioned jumping to a subroutine. The commands in Omron is just that, jump. When you come to a certain point, you can just say, if this is enabled, it will jump or skip over sections of code to a certain point. Now, what's this look like? Well, I could have a couple of rungs here, and I can have a start button there. I can put a couple of rungs here, and I can copy that, paste it in here. I can put an output. What's our actual system? Put an output in there. Now, if I instead had this sensor, I could actually insert a jump command. Now, what am I going to jump to? So you can pick any object. You might have a unique name or unique sensor. I could say, I could set an input put something in there. And when this variable is set PB4, so I can just say PB underscore 4. So when sensor A gets pushed, it will then jump. It searches the program for something called, for a label PB4, and it would find it here. So then it would start, I should probably get rid of that. It would start executing it. So basically, here's a small example. It would jump from this point right to PB4. So it's going to skip over rung 1. Rung 1 would not get processed. So that's what a jump command does. Of course, it's not happy. My build command say. Anyway, so that is what a jump does. So you can jump over under certain conditions, don't process a couple of rungs, skip over them, and carry on beyond that point. So that's a jump. Now, the other thing you're going to get into sometimes would be set, reset outputs. So I can get rid of the rung. I can get rid of that. I can go back and put I can put an output in here. So if I set and reset is like a latching relay. A set, this is the only time you can use the same output name twice. I can right click on that and say, make that a set instruction. When sensor A is pushed, the conveyor output will be turned on or set like a latching relay. Sensor A can then go off, but the output is still latched on, locked on. It will stay on until the conveyor reset output is energized. Now, sensor A could set this. Sensor A goes off, the output stays on, the conveyor keeps running until sensor B. Object passes sensor A, starts the conveyor. It runs until the object passes sensor B. It resets that output, conveyor goes off. And again, these can just be pulses to make this occur. Now, be cautious. This is a dangerous sort of situation. Even on a e-stop or power outage, say the power flips off, when the power comes back on, conveyor can still be set. So it might start up and run right away. You're better off to use a start-stop, push-button, holding contact type of arrangement, because once it's stopped, you actually consciously have to walk over and start it up again. You may want something like this. Maybe it's your shop compressors or some refrigeration units that after a power failure, everything starts up. These must be running. You don't want to have to wait. If you get a power outage in the middle of the night, you don't want to have to call somebody in to go start up the refrigeration units again. So in that case, you could use those things, but they do need to be used with caution, right? So that sort of sums it up for this week.